today we're going to begin our last lesson in the unit on transformations. So first we did translations, which are slides. Then we did reflections, which are flips. We did rotations, which are turns. And now we're going to do dilations, which is when you make the figure either larger or smaller. So here on our note sheet, the directions say, answer the following questions to the best of your ability. For the y-axis, use the same scaling as the x-axis. So in math, the word dilate means to either enlarge or reduce a figure. If a scale factor is less than 1, then your figure gets reduced, which means it's smaller. If the scale factor is greater than 1, then your figure gets enlarged, which means it becomes bigger. So number 4 says, graph the dilated image of triangle JKL using a scale factor of 2 and 0, 0 as the center of dilation. So 0, 0 here is just the origin. That's where we're always going to dilate from. So first thing we're going to do, just like when we did the other transformations, we're going to name our original order pairs. So we're going to start with point J here, and we're going to say point J goes right 2 and up 1, 2, 3, 4. And then we're going to name point K. So point K goes right 1 and up 1. And then point L goes right 4. And then we're going to stay right at 0. So now we're going to look at this. It says graph the dilated image using a scale factor of 2. Well, 2 is larger than 1, so that means that our triangle is going to become larger. We're going to enlarge it. And all we're going to do is multiply all of our coordinates by 2. So if J is 2, 4, then J prime, we're going to multiply each one by 2. 2 times 2 is 4, comma, and then we're going to multiply the 4 by 2. 4 times 2 is 8. Then K prime, we have 1, 1 for K, so we'll multiply each one of these by 2. 1 times 2 is 2, and 1 times 2 there is also 2. Then we're going to multiply L prime, or L rather. 4 times 2 is 8. And 0 times 2 is still 0. Then we're going to graph this. So J prime is 4, 8. So right 4, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to put us up here. That's J prime. And then K prime is 2, 2. So right 2 and up 2. So that puts us right there. K prime. And L prime is 8, 0, so right 8 and stay right at 0. And then we'll connect here, connect our points. That's not very neat, sorry about that. And notice we have a larger triangle. Okay, so number 5, it says graph the dilated image of quadrilateral MNOP using a scale factor of 3 and the origin as the center of dilation. So scale factor of 3, so this means that we're going to have an enlarged quadrilateral. So point M, we're going right 1 and up 3. And point N, we're going right 3 and up 2. Point O is at 2, and then we're going down, so negative 2. And point P is going left. So negative 1, comma, and then we're staying right on the axis, so negative 1, 0. Okay, so scale factor of 3 once again enlarged. So we're going to take point M and multiply these by 3. So 1 times 3 will give us 3, and 3 times 3 will give us 9. And then for N prime, same thing, multiply by 3. 3 times 3 is 9. 2 times 3 is 6. It's supposed to be a 6 there. And O prime, so multiply by 3. 2 times 3 is 6. And negative 2 times 3 is negative 6. and P prime, so negative 1 times 3 is negative 3, and 3 times 0 is 0. Okay, now we have to graph. So M prime is 3, 9. So right 3 and up 9. 1, 2, 3, 4, 5, 7, 8, 9. So all the way up here at the top would be M prime. And M prime is 9 down here on the edge. And up 6. 1, 2, 3, 4, 5, 6. N prime. And O is 6. And then negative 6, so down 6, 1, 2, 3, 4, 5, 6, all the way down here. And P prime is negative 3, 0, so left 3 and stay right there at 0. Okay, and then connect. And there's our larger quadrilateral. So you might want to try this one on your own, pause it, and then come back and check yourself. It says graph the dilated image of quadrilateral MNOP using a scale factor of 1/3 and the origin as the center of dilation. Okay, so let's name our points. So point M looks like we're going right 3 and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. And point N, we're going right 6 and staying at 0. Point O, we're going right 3 and down 1, 2, 3, 4, 5, 6, so negative 6. And point P, we're going left 3, so negative 3 and staying right at 0. Now this one says your scale factor is 1/3. Well, 1/3 is smaller than 1, so that means that this is going to be reduced. It's going to get smaller. So we're going to take M prime here. Okay, so M is 3, 9, and we're going to multiply by 1/3. So you might want your calculator there. 3 times 1/3 will give us 1, and 9 times 1/3 will give us 3. Because you're basically dividing by 3. Multiplying by 1/3 and dividing by 3 are the same. Okay, and then same thing, we're going to come down to N, so we can find N prime. So 6 times 1/3 is 2, and 0 times 1/3 will give us 0. And now let's find O prime. So 3 times 1/3 is 1. And negative 6 times 1/3 is negative 2. And let's find P prime. So negative 3 times 1/3 is negative 1. And 0 times 1/3 is 0. Then we're going to graph. So M prime, 1, 3. So right 1 and up 3. So M prime. And N prime is 2, 0. 2, 0. And O prime is 1, negative 2. So right 1 and down 2 for O prime. And negative 1, 0 for P prime. So left 1, stay right at 0 for P prime. And then we're going to connect here. Oops. And there's our smaller quadrilateral. Okay, last example here. It says describe the dilation of quadrilateral MNOP using the origin as the center. So let's name our M, N, O, and P first. So, whoops. Alright, so M is located at 3, 1, 2, 3, at 3, 3. N is located at 9, and 1, 2, 3, down negative 3. O looks like we're going left 6, so negative 6, and down 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last one, P, looks like we're going left again, negative 6, and up 1, 2, 3, 4, 5, 6. Now let's name our prime points. So M prime is at 1, 1, and N prime is at 3, negative 1, and O prime is at negative 2, and 1, 2, 3 going down, 3, negative 3, and P prime is left 2, so negative 2, and up 2. Now, the original question said, describe the dilation. So clearly, this quadrilateral is getting smaller, so it's reduced since it's getting smaller by, well, what are you reducing it by? So M was 3, 3, and now it's 1, 1. So you're dividing by 3. Let's see if that's true for everything. N was 9, negative 3. Now it's 3, negative 1. So once again, dividing by 3. O was negative 6, negative 9. Now it's negative 2, negative 3. So once again, dividing by 3. And P was negative 6, 6. Now it's negative 2, 2. So once again, dividing by 3. Well, dividing by 3 is the same as multiplying by 1/3. So it's reduced by 1/3 or dilated by 1/3.